Hello friends, I Agrawal, yes, Assistant Professor in Civil Department, Sandipani Technical Campus, Lect. Today's topic is a derived expression for slope at support and deflection at center of simply supported beam subjected to medial throughout the span by Macauly's method. Learning outcomes. After watching this video, student will be able to understand the concept of Macauly's method, and also student will be able to find the slope and deflection of determinate structures. So now here we are considering the simply supported beam. Which is subjected to UDL throughout the length. This is W kilonewton per meter and the span is the L. So find slope at support and deflection at center. So our first step is to find the reactions. So by symmetry we can say that reaction is RA is equal to WL by 2, and here RB is equal to the WL by 2. So by the differential equation of the elastic curve, EI d2y by dx square is equal to the mx, is the bending moment of the beam. So here we have to make the section. So here is only one section because of the this is one force and another force. You have to make one section only. There is no change of the load beyond the one section. So if you consider the x from the generally the left side in the Macauly's method. So now the bending moment equation, mx is equal to, now from the left side we know this WL by 2 into x, then minus this intensity is a Hung bending moment, W into x into the x by 2. So W x square by 2. So put this mx into our equation of differential equation of the elastic curve. So we can say that EI d2y by dx square is equal to the WL by 2 into x minus WX square by 2. Now here don't show the section because it is only one section. It is only one section. Then integrate this. Integrate both sides. So this becomes here EI dy by dx is equal to WL by 2 into x square by 2, then minus W by 2 into the x cube by 3 plus the C1. This is a constant of integration. So this we call as a slope equation. This is a slope equation. Again integrate this. Again integrate both sides. So this becomes EI y is equal to here WL by this 4, 2 into 2 4 into here x cube by 3, then minus W by 6 into x raised to power 4 by 4 plus integration of C1 is C1 into x plus add here the one more constant of integration. So this is called as a deflection equation. This is called as the deflection equation. So we modified EI y is equal to this WL into divided by the 12 into x raised to power 3 then minus wx raised to power 4 divided by 24 plus the c1x plus the c2. Now our aim is to find the value of the c1 and the c2 constant of integration. For that we have to apply the boundary conditions. So boundary conditions. When x is equal to the 0 means at the support A here, when x equal to 0 here, so deflection is equal to 0 because at support there is no deflection. So we can say that here y equal to 0. So put this in deflection equation, in the deflection equation. So we can say here is deflection equation. So 0 is equal to here this WL by 12 into 0 then minus W by 24 into 0 plus the C1 into 0 plus the C2. So we can say that C2 is equal to the 0. Then we apply the second boundary condition here because we again want the C1. So boundary condition what is that condition? Is x is equal to the L means at the support B. So y is equal to the 0 because x equal to L is the at the support B. At support B again the deflection is 0. So y is equal to the 0. So again we have to put this in the our equation of the y. So y this equation. So y equal to here x equal to L, y equal to the 0. So 0 is equal to here WL by 12 into the this L cube then minus W by 24 into L raised to power 4 then plus the C1 into L and plus C2 is equal to the 0. So this is equal to WL raised to power 4 by 12 minus WL raised to power 4 by 24 plus C1L. So C1L is equal to, this becomes the positive WL raised to power 4 by 24 minus WL raised to power 4 by the 12. So this becomes here the C1L is equal to this is minus WL raised to power 4 by the 24. So divide this L. So this C1 becomes the minus WL cube by the 24. So in this way we got the value of the C1 also. C2 is equal to 0 and C1 is equal to the minus WL cube. So next is to find the slope at the support. Slope at the A. Slope at A. So first we write the slope equation. For the slope at A, we have to put x is equal to the 0 because slope at A, it means at the here. So this is our deflection curve here like this. So we want here the theta A or IA. So this is the IA. So we have to put the x equal to 0, then we got the IA. So this value we have to put in the slope equation. So x is equal to the 0, this dy by dx is become the IA and put this in slope equation. So our slope equation is EI dy by dx is equal to WL by 2 into x square by 2, then minus W by 6 into x raised to power 3 plus the C1. So we know the C1 here. This C1 is minus WL raised to power 3 by the 24. So we have to put this value in this equation. So here x equal to 0, dy by dx becomes the IA. So we can say that EI IA is equal to here is 0. X equal to 0 means total term is 0. Then this term becomes the 0, 0 minus 0, and C1 is the minus WL cube by 24. So we got the IA is equal to minus WL cube by 24 EI. Here this negative sign indicate the slope is the clockwise. Then the slope at the B. We know that by the magnitude, the slope at the A and B is the same because of the symmetry. But this slope is anti-clockwise. So it's clockwise is negative, so anti-clockwise is a positive. So we directly write here the slope at B that IB is equal to the plus WL cube by 24A. So in this way we got the slope at the B. Then next part is the deflection. So we have to find the deflection at center. Deflection at center. For that we have to put the x is equal to the L by 2, because at center means center of the span, L by 2. Here at center. Suppose this point is a C. So this is the L by 2. So we have to put x is equal to the L by 2. So this y becomes the YC at the center. So first we write here the deflection equation, that EI y is equal to WL by 12 into x cube minus Wx raised to power 4 by 24 plus the C1x plus the C2. So we know that here is C1, this value is the minus WL cube by the 24, and this C2 is equal to the 0. Then EI y becomes the YC is equal to WL by 12 into here, instead of x here is L by 2. So L by 2 bracket cube, then minus W by 24 into L by 2 raised to power 4. Then C1 is minus WL cube by 24 into the L by 2 because the x, then plus the 0. So this becomes EIYC is equal to, this becomes WL raised to power 4 by the 96 minus WL raised to power 4 by 384, and this becomes minus WL raised to power 4 by the 48. So algebraic sum of these values are EIYC is equal to minus W5 WL raised to power 4 divided by 384. So final YC, we can say that final YC is equal to minus 5 WL raised to power 4 by 384 EI. Here negative sign indicate a downward deflection. Downward deflection. So this is our final answer. Deflection at the center. Thank you.